just so I can remember his name and what he looked like.
Everybody ready to go? We'll start a couple minutes early here. Well, welcome. Last year when we did this, we went a little bit informal. We had loud questions throughout. The fuselage is the second half, so just know that part's coming, the second half of the presentation. But if you have a burning question, we might take those in the middle. We might just keep on going. So welcome. This is on the RV-15. How many people are building an RV-15 right now? That's quite a few hands. How many have both kits? This is great. Thank you for building. I know there's a lot of interested parties. Hopefully if you're not building, you're either helping your friend build one or you're soon to start one. So with that, engineering insights and innovation, we'll get through the RV-12 here at the beginning. So the 12IS, there were a few changes, of course, that had to be mosaic compliant. Beautiful picture of where we get to fly in the Northwest there. There's a new requirements under mosaic. There's a rollover test that was added, so that's 4,200 pounds loaded on top, and then you have to count for it sliding backwards. So we do that with all the airplanes. The one thing I would mention if you're building some other RVs, that center brace that's on the roll bar, it's there for a reason, because otherwise the roll bar won't stay upright. So once you flip over, you will slide backwards. So we have 4,000 pounds up there, and there's a forklift you can't see outside the picture. That blue arrow is indicating that. And you have the half of that pulling the 2100 pulling forward, simulating friction on the roll bar. Survive that was fine. The other test that you have to do is seatbelt release. You have to prove that upside down, if you're hanging in a tree, you can release the seatbelt. That's an M-safe seatbelt. Just FYI, I've tested multiple seatbelts now, and they're harder to get open if you're hanging in them like that than you think. So you got to really yard over on it, but it did come open. So that's just an example of the new tests we had to do for mosaic. You also have to have a CO detector on a mosaic. Now that could be just the Home Depot variety that you replace. So it's not a hard requirement. We include the Ethereum model. Moving on here, IFR IMC. So we developed with BNC a proprietary little alternator that goes on the back. It outputs 12 amps. We'll offer that to all RV customers, going back to the RV-12 ULS. So if you're a ULS customer and you run out of juice, so to speak, we'll offer you that. We're still debating whether we're going to sell the PO with it. Of course, you go out and get the PO if you want to go on IMC. Maybe you just want the extra electricity, because on the ground with everything on, you can run the battery down on any Rotax installation, even an IS. And that's letting me know I'm late for a meeting back at Vans, but I don't think I'll make it. We have alternate static, wing-mounted heated PO, so it's out of the spinner. You can now mount your Ruger 1022 in that same location, and auxiliary alternator. So again, we're going to offer that. C-Vans, after the show, we'll start offering that up as a separate. It's a great little design. It's compact. It's no longer mounted out on a cantilever that drove some of the other designs to failure points. So we think we have it made. This is kind of a lot of pictures in one picture, but we added a cargo net. I know traveling along in the 12, setting something on top of a cargo net is a enjoyable thing to do. So you don't have to reach down to the baggage, you have a little extra shelf. New control sticks from Toston. We added an LED strip across the glare shield instead of the one up on the roll bar that's a lot more effective. A crash hammer. So if you don't have a crash hammer, please put one in your RV. We had a gentleman repair his carburetor. He thought everything was okay. Took off, couldn't make it, rolled, put it back down on the runway, ended up rolling to the end and rolling up, flipping the airplane up into a tree. Now he's sitting straight up and down and he can't get out of the airplane. So you may not flip all the way over and have the flexi brake. He ended up somehow having enough tools in the airplane to take all the screws out carefully and get out. Anyone who's built a canopy on an RV, you don't want to rebuild it on. Anyone who has worked on the fuel system of an RV-12 and tried to crawl over the fuel tank knows it's an unpleasant experience. We'll get into that a little bit later on the 15, how we didn't design it that way. But on the bottom of the tail cone, that upper right picture, there's now an access hatch. You can get up in there, and if you want to order this installed in your older airplane, please do. But get up in there and structurally compliant. And you can easily pull the filters out, get to the fuel pumps. Great addition. And now we have a parking brake as well on the airplane. I never thought I'd need a parking brake, being like van. We're conservative, we don't want an extra ounce, but I do enjoy the parking brake. And on to the RV-15. So first I want to make an announcement. We promoted Brian to Design Engineering Manager. So he has a large portion of the engineering team, all but 2 of them underneath him working the 15 project. We eventually will be working about 3 projects in parallel. But Brian will be designing the 15 and probably the next 16 as well. So it's been well, we have to keep you advanced and force you to help us build a prototype. I mean, you sign up for that. So I just wanted to quickly go over this. You've seen this before. But of course, the goal was to cruise with the other airplanes, the 180s, 182s. I didn't fly to Oshkosh in the 29-inch wheels. I just hate to break it to you. Flew on 8.5s, and then we switched them out once we got here. Just trying to save those wheels on asphalt. But on the 8.5s, I was getting about 137 knots at 65% power, 9,500 feet. This airfoil loves 9,500 feet. That's the sweet spot. So it's custom airfoil, and that's where it likes to cruise. Capable of unimproved strips and take the stuff you need. Of course, we have double baggage capacity of a Cub and designed for Mosaic. Now, I saw very few hands go up in yesterday's meeting, but what Mosaic really means to us, the experimental community, is in ELSA, there's no more a 51% rule. And in the long term, I think that's going to be more and more to the community. It also means that, experimental never had a rule that defined it. It could be slipped away with a wipe of a pen. And so even if EAB disappeared, we still have ELSA. So in many ways, it has been an addition to the industry. Gets the load at 900 pounds, stall speed of 45 knots. That's a gross weight, and I can tell you the stall speed's less than that. When you're medium loading, you're down into the upper 30s easily. The speed, we've never let that out, but I'll let you get close to what we're looking at. Speed 140 knots. Again, I'm getting 137. We haven't put on intersection fairings, etc. So we believe we can easily make 140 knots, especially if you put wheel pants. You're going to be well on past that. And 2 seats plus real baggage. So it's a side-by-side version of the Cub market is what we're after here. Takeoff landing distance 400. And then the engine choice, again, I'll put this back up here, 175 to 220. So I've got a lot of questions on that this week. At 175 horsepower, you're talking an engine that's probably around the 270 to 285 pound range. You will have reduced baggage capacity with that, but it'll still fly well. So if you're at a low density altitude like the eastern US, airplane would still operate fine. But you're going to need that extra weight. So in that case, you probably want a metal prop. You need the extra weight of the angle valve or the 390 or even an IL-360, 200 horsepower angle valve. Be a great pairing with this airplane. So let's talk about the tail. When we started out with the tail, we wanted to maintain the RV control harmony, a sufficient pitch authority. We have 3, one of them's right here, 3rd row, Dave Schwartz, and he wrote the standard in Mosaic for ski planes. He's that interested in them. We have 2 other customers besides you, a couple on social that want to fly on skis. Well, if you're coming into a glacier, or even the rest of us coming to a really sloped airport, you have to have pitch authority. And although at AFCG we had pitch authority, mid-CG range, it was just you 2 guys flying, 2 ladies flying for fun, whatever the thing may be, and you come in and you want to flare that airplane to land on that pitch slope, you would run out of elevator authority. And that's why you see a lot of airplanes goosing the power, trying to get flow over the tail. So we knew we needed more pitch authority. We started out with the stabilator, and what would happen is there's too much going on at once. So that's why it was too pitch sensitive. It did save weight, and of course we had the weight and balance change, the airplane getting rid of the stabilator. But if you're coming into land, and everything is stable at that point, and now you pull 220 horsepower off, you dump very large flaps, pretty much the same size as a Helio Courier. You're having two huge changes at once, and then the stabilator, which is a little bit pitch sensitive at the same time. Pilots just couldn't handle that easily. We could learn it, a couple of hours, but I felt for the average pilot who wanted to go back to a conventional tail. We also needed a tail that had full authority at 35% MAC. That's the same as a Cessna. So if you're carrying 250 pounds of baggage, and it's an aft CG, you want it handle safe, track straight, and be stable at that condition. Just the status of the project. Brian, why don't you go through these?
Absolutely. So as you know, the wing kit and the tail kit are now shipping, and we've had lots of good feedback, both the challenges in the wing kit and KI updates, and we've incorporated a lot of that into the tail. But working through the tail, we've made a number of improvements that are going to get baked back into the wing and forward into the fuselage. So I'm sure you've all noticed that your elevator doesn't have trim tabs. That's all in the new horizontal trim system. We put a lot of work into the production trim system, landing gear design, fuselage, the baggage door. There's a significant amount of details that all get finalized, structural analysis. And there's many ways to accomplish something, but there's really only one right way, the RB way, as we work our way through this. So it is truly the case, right? We'll design something once, not quite like the part count or the tool access or what have you, and have to really take another shot at it before you guys end up with your pieces and those frustrations. And we just keep working our way through and polishing the airplane, both to make it perform, keep the structural weight down, but make it a great experience to work on and build. So the current project, we're cutting metal for the fuselage. So the structural analysis is at a gross level quite done, and we're working through that to get to the static testing. And in parallel, as that prototype fuselage is being built, we're doing the really detailed stress analysis that'll prove that your airplane has many thousands of hours of good, useful life. So that is the fatigue analysis that we as a company have the resources to perform. That is something that you can't quite discover with just normal structural load testing. So lots and lots of exciting work there. We have completed the spin test now. I'm sure you guys saw the videos. We had LAP went up to do a very accelerated spin program. We didn't cut any corners on the program, but we had some long days and lots of spins. So I think we were up for the 70 plus spins, and it was a pleasure to work with them, and the airplane performed flawlessly through it all. So we had all these mitigation plans, all these little details, and it was great. Of course, the final airplane, we've changed enough that we'll go through it again, but we have complete confidence in the aerodynamics of the airplane, and are really excited to keep moving along with that final fuselage shape. The influences that those tweaks we're making to the fuselage have all been mitigated through that test program. And the team is now working on the KIs for the fuselage as we build those structural test articles. So it's a great opportunity to adjust the bill of order, adjust parts for tool access, and adjust some of that forming tooling to make sure you have that good natural feel.
In case you didn't detect it, I got the slides out of order. Back to the tail. So I pretty much explained this. We chopped the volume on the tail. Last year, the tail was a tail volume coefficient of 0.68. That's the same as the large Cessna. And we knew it was too large, so we chopped significant amount out, chopped about 30 pounds out of the tail doing that. It's amazing, a little reduction in area, how much it reduces the bending moment. And so what we have now is a tail approximately the size of RV10, using a jack screw to get that pitch authority. The benefit of a jack screw is at any trim position, you still get full elevator authority range. And Brian and I flew it.
You guys say it was flying at 180? Any hands in the air? Yeah. So I mean, spectacular power in the flare. You have that full elevator deflection, especially with a big flat airplane, and it is really a slick solution. Cessna did it right on that one, and we really drew inspiration.
Right. So we know we had to go to the jack screw to get the authority that we needed for the conditions that I specified earlier before that slide was out of order. And so with that, Brian has designed the jack screw. There could have been a few pictures that were taken in NTSB crash yard that ended up on his desk, and he took it from there. So Brian, I'm going to get a clicker as well.
Absolutely. Yeah. Speaking of having to design something multiple times, trying to keep the maintenance low on this, keep the load pass really clean. We're really proud of this final iteration we have on the jack screw. But if you'll see here, it's lightly highlighted orange just in front of the forgot all that. You can't do stuff all the time. So this lightly highlighted orange section, that is the location of the jack screw. We're going to work our way into what it looks like, how it goes in and out of the airplane, how it's adjusted, and what that looks like structurally, the design work that we behind it. So if we work our way, right click on it.
Okay. I'll click right.
Thank you. So let's take a little zoom in here. So what we have here, we have twin jack screws. Those of you who work on the Cessna, you'll see that is a similar arrangement, but these are substantially larger. We have full structural redundancy in them. One jack screw can take the entire load of the tail and all the adverse conditions. It moves the tail through a 10-degree trim range, and that's quite a lot. And what that is a result of is our large flaps and really wide speed range. So being able to trim the airplane with that much flap to a higher approach speed, well, maybe that's for a descent or what have you, requires quite a bit of trim power, especially to maintain that full elevator authority and completely eliminate the trim tabs. The tensioning system that's electrically driven, we have a motor that is centralized on a very small chain loop. And to give you a sense of scale, I mean, the distance between the jack screws is, the fuselage width is not a lot at that point. The chain breaks, and we have the structural redundancy that the jack screws just will fail stop to say. That is a result of the thread design. It's a triple start, lead screw, lots of structural margin in that. And part of what we're doing there is to keep the stresses low so that they don't wear out. You don't get these big sloppy screws that then need to be replaced with the expensive machine part. They're just our lifetime screws. So as we start to look at how it integrates the fuselage, you'll see we've added these two rings. And those are doubler rings on the tail cone on each side, providing access to inspect and remove the screws. Those doubler rings have flanges integral to the trim motor tray, so you have a fully boxed out structure. Nothing is hanging or flexing or what have you, even if it drives into the stops. It does have limit switch stops, but it has mechanical stops that can take the entire tail load, and the screws in the motor can't overpower them. So physically stopped top and bottom for safety. Those clips above are attached to more fuselage structure that prevents them from overextending. Should the limit switch fail, they just can't come apart.
I guess the one question I have, let's say you have electrical failure out.
Yep.
Is there a way to manually neutralize the stabilizer?
There is not. So electrical failure in flight, the airplane's plenty controllable. We have flown it in fixed positions, and that's actually one of the risk mitigations we did as we were developing this. Like, well, we need to make sure we like it before we put all this time into this mechanism. We flew it at fixed positions with the trim tab eliminated from the airplane. That did two things. It improved our range of trim, and it improved the controllability of the airplane, which I had some nerves about, but it was really quite modest. The airplane performed really well across the different speed ranges and throttle positions. And essentially, should you fail in the field, the way this is mechanized, the only way to really drive it is through the electric motor. The failure that would have, it's a fairly inexpensive gear motor. It could be replaced it may be a fuse, it may be broken wire. So there's certainly other ways to troubleshoot.
But I would say, we have good access at the back, and there is a connector right there. I'll get into that in a couple more slides. So there is a connector back there. You can just unplug the connector, take your any old battery, and move it there. If it isn't the motor that's the problem,
Right.
Yeah.
But as far as a full mechanical redundancy, that would be a significant amount of weight and create more failure modes that then we would have to consider.
It is a good question, and we thought I think we have a defined connector, but I'll think about it again. I think we'll stay with the connector we have. I didn't think of that. So thanks.
Yeah.
The Cessna, you have to completely remove the vertical and the horizontal to get to the screws, and ours are fully accessible. Just work on them from the front side of this bulkhead. So really thinking about the mechanic and how they get in. And if we come to the next slide, right? We have the chain tensioning system. So what we have here is we're looking for a chain that indexed to the gears with significant wrap angles, is what we would call it. So you can see the one on the right, we have a full 180, we're darn near it on the left. And the driving motor is in the center, very specifically off of one of the screws so that they can't drive and abuse the other screw should there be a chain failure. And this idler gear here slides on a carriage to tension the system. So we don't run much tension in it, but it's really easy to adjust and lock into place. The loads are quite balanced, and it's very easy to take it all apart. You can take the tension out of it, pull it off the driving motor gear, and the chain will come off the screws, and we go through. So how do we get it apart? So a lot of these pictures are quite large, but really this entire tray, again, is quite small. So getting in there to say like a safety wire or a cross pin pivot bolt would be a real pain. We didn't want to have to bolt through the skin, have another access panel, what have you. So what we developed are these machined bathtub fittings, essentially. They have these carrier plates on the side. You pull the plate off, the jack screw, move the control rod over to the side. If you want, you actually remove it even with it centered. But there's lots of light there with both of them removed. There's 4 nuts on top of the gear motor. It drops right out the bottom of the tray, and you pull it out through the hole. So these are all quite small parts, but very easy to remove.
Empennage steering, just really quickly. We got a question back, yeah.
Yeah, so if you had a failure in the motor, could you do that untensioning of the chain and put it back on the sprocket in the middle position so you don't have to fly 2 hours back to home with full elevator forward and aft, making it harder, a little harder to fly?
Could you retension the chain was the question. I'll let you.
Yeah, so 2 routes there. You could adjust that slide idler carrier to remove enough tension that you could pull the chain loop through to recenter it. You could also pull the driving sprocket off the gear and pull it through and put it back together.
Yeah, so real quick, don't want to spend much time on this, but
we will have a Q&A.
We'll have a Q&A, yeah. The empennage fairing is very much like a 180 where you have a metal piece that slides inside. The bottom side of the prototype airplane over there is not what you'll see because we have different structure. It'll be kind of the same arrangement as you see on the top side. And then again, these are prototype fuselage, prototype fairings. But the final configuration is what you'll see on the top side of the picture there, where you have an aluminum piece. Can you see my mouse in there? You can. Okay, there's an aluminum piece that slides up underneath the empennage fairing. So it's all enclosed. I think it looks beautiful for what we're up against with the jack screws. So well done there. Logan designed that at Vans, composite guy that we just hired, and Soul guy as well. Stabilizer testing. So when you test the empennage, you have to have a load that's partially on one side, 75% on one side, 100% on the other. And if you do the math, that actually takes all the load off of one of the connectors at the front and puts it all onto one side. So now you see why we made the jack screw the size that we did. This is the ultimate load. Those are bags of lead shot. That's a lot of weight. We joke that that's more weight than Van put on the RB5 wing. The stabilizer here. And I want to show what that looks when we get to the jack screw. So this blown up picture on the left-hand side, at ultimate load, we disconnected one of the front jack screws to simulate that a jack screw might wear out over time and stripped, who knows what. And if you had to go up and down and operate this airplane at ultimate load on one jack screw, you could do so. There's so many issues with so many airplanes with jack screws. We just want to assure you, we wanted to first assure ourselves that we had a safe design. And so that's why we went oversizing the jack screws and the level that we went to in testing. This is vertical rudder testing. So we went to great effort to reduce weight because every pound at the back means you get to carry more baggage. It has a great effect on that. Lost about 1.5 pounds through that testing, going to some lighter weight skins. Tail wheel, why don't you take that?
Yeah, so the tail wheel assembly, we've talked about that since the prototype airplane, and it's greatly survived, or overall survived, as it was initially drawn. But what we did is we moved to the production airplane, motor airplane, really targeted weight and ease of maintenance. So let's say you want to remove the entire thing once you put it on a float plane. So structural concepts, the shock itself, how the full swivel tail wheel and its locking mechanism works, it's all fans now. Those parts exist. Those parts we have been working on assembling and putting in the structural test. But what that really means and where that work went is we pulled the 4 pounds out of the tail wheel itself. Some of that's shock and swivel mechanism, some of that's fork. A lot of it is the attach point in the fuselage that is driving that parallelogram mechanism that we've spoken to at length before.
Just want to recap the tail building. Yeah, we want to get you in here, Louise. So just 3 quotes there. I think everybody's enjoying their tail kit. It will build in 2 weeks. A true joy to assemble and put together very fast. That was off Louise. Thank you for that quote.
The entire engineering team was quite excited and tracking the thread, and especially after early growing pains with the wing, as we're really taking that feedback and taking it forward and improving everywhere we can. And we know how frustrating it can be, get 2 less and you should have had 1 of each, or this build order maybe could be improved. But we're going to keep going. That's an early airplane thing. We really took a step up on the tail kit. We did more prototype builds at the factory, really looked at every which error we could find, and I think that's really paying off for the customer experience.
And we're working on that right now on the fuselage kit, so bringing the same level for the fuselage. Fuselage kit, so on to the next part of this story. As you can see, we're well along. We're producing parts right now for the fuselage kit so we can get to static tests. So let's talk a little bit about ergonomics. We did move the wing 4.5 inches back and the engine forward, so the net move is about 6.7 inches. And then we went back and we looked at the 5th percentile female up to the 95th percentile male. Now, last year we showed you a 7-foot individual in the airplane, if you remember, so it will take taller than that, but that's about 6'4" down to a 5'2" person. And one of the things that I've noticed fitting different people in the airplane, I also have short legs, long torso, is that we needed a greater adjustment range on the pedals than we had in other RVs. And so as a result, we also wanted to move the occupants forward to even give more baggage capacity for that 250 pounds, to get from 200 that we promised you when we debuted the airplane to get it up to 250. So the occupants move 5 inches forward. The panel moves 5 inches forward as well. So you see, a dashboard right now on the prototype that you put a pizza box on for in-flight refueling of the pilot, and that will go to a normal size panel space. Improved visibility around the A-pillar. I'm looking forward to this. You kind of feel like you're a little bit too far. I know on the photo shoot last year, we felt we were trying to look for an airplane. So that 5 inches further forward and the A-pillar sweeping back, you should have better visibility around the front. We kept the bottom of the A-pillar where it's at for more door opening access, etc. Rudder pedals, it will at least be fixed but with a greater adjustment range. So there's the 3 holes that you have on RV14. You'll see the same setup in the prototype 15, but the final version, if we keep fixed pitch pedals, they will be adjustable further back for you. In fixed positions, we do have an adjustable pedal that we're looking at. I'm not going to guarantee anything that might come out for the airplane or will come out eventually. And then here you see a side view. So you see the lady up in the front and the gentleman in the back, and they both have the same sight line over the cowling. And we have a seat design. I'm not going to show it yet because it still needs some weight refinement. I didn't want you to prejudge it. But it has a 4-inch vertical arrangement and throw. We're sliding back and forth on the mil-spec gun rail that you would mount scopes to, tactical rail. And then it'll have a pin system similar to an RV-10 that clicks it into different positions. But that rail should allow, it's lightweight. It's not the Cessna rail. It's not going to have the issues that the Cessna rail has. So the airplane that you see out there still has Cessna 152 seats. There's a better seat coming, and it will allow you to adjust up and down easily. The same visibility for all occupants, and then the stick. Of course, those who've flown an RV know when you pull that stick back, and it's really important in a tail dragger, you don't want it to come into you, the pilot. That's the most important thing. We also want a panel clearance and then control clearance. You'll see that the initial airplane, if you look carefully at those sticks, they were ground off because it would hit the throttle. And now we have ample clearance to the throttle, so you're not going to come forward, you know, and wheel land, pin it, and go back to full power. You don't want that. We've cleared all that out. The fuselage that's final will be wider by about 1.5 inches from what you see there as well, to try to get more width at the front end for the pilot in that forward position. RV-14 size panel, for those that you are thinking about it, it's a little bit bigger around the edges, but if you're thinking about panels, we plan on offering a panel from Vance, of course. It will come in an avionics kit, but just to give you an idea of the panel space. And we have a very narrow tunnel that has angled sides, so as you articulate your leg over, it's even going to be better than a 14, so you don't rub your leg on the edge of the tunnel. Looking at the flash system, there's been a lot of questions. The system that you see on the airplane out there has cables inside. We just did that dirty. We mounted the flap on top of the floor. It's really flimsy. And so Brian, why don't you talk about flap, and I'll go to the next slide here in a second.
So of course that is the development airplane, and a lot of it is how do we get it done once as fast as possible. So across the entire fuselage, the structural concepts, the control system routing, what have you, everything is updated in this airplane. It is substantially more leaning into machine components, just that fit more weldments, but away from the really hydroformed and more traditional Cessna type airplane manufacturing that we were doing. Now, with the flap, again, that's that same theme as we had, you know, it was a stick-on to the old airplane that had a completely different Cessna logo on the roof. This airplane now has been designed with the flap from the start, and its cable routing and ergonomically, all the clearances, the controls as we package everything in for ease of access and really to keep it out of the way, keep it out of your sight line, and make it so just not something you have to think about. So the flap handle itself, we've even shifted it forward yet from the current airplane we're looking at now. That is its third iteration. This one is now the fourth in the production iteration. The handle got just a bit shorter. It sweeps through more angle, but it's in a much more natural location across the different 5th to 95th percentile people as we work through all this ergonomic evaluation.
It's light forces, so even if you're in the forward position, which is what I've tested out, you know, you come back like this, but there's a pull to get in the fourth position, but it's definitely doable, and it's really light forces up to that point. So we put a lot of thought into this, the position of the flap panel, the flap forces. We needed the cable system to get the full 45 degrees, so we needed that extra tension. That's where that came from. So looking at the routing, again, it won't be like you see in the airplane, but it will route to the center, back into the baggage area, down, and then back forward again.
Yeah, so all covered up. You can see there how it drives in the wing. I know we've had lots of questions, so we're going to dive into that a little further. But this cable system that we're running, we're able to get a lot of mechanical advantage, a lot of work into the system to keep those flap forces low for you. So there's a lot of parts that are getting a little bigger mechanically, just so that we can keep cable forces low. That keeps the deflections on the system low, so that the whole system is effectively stiffer. It keeps full deployment through the speed range. And it's all nice and hidden and clean. The first two flap positions of the drying set are effectively just fingertip out they come. The handle comes up into a nice natural, stronger location for a person. And for those last two, it progressively appropriately ramps that flap deployment force. And trying to encourage you to keep slowing down the airplane, which is really what we're looking for, right? We're trying to slow the airplane down if we're looking for the third position and the fourth.
not to go too much into it, but if you just depress the button and leave it depressed and let the flap float in cruise, it will float to somewhere near the flap 1 position, which means you're kind of reflexing the airfoil for extra cruise speed. So if you think about dumping the lift, if you're on downwind, you put it in flaps 1, now it's easily accessible by anybody, easy to reach, and then you're ready for the rest of the maneuver. And if you want to dump all the lift, you really don't need to dump into reflex, you need to dump into flap 1. So you have a shorter range that you can operate the flap in if you're trying to dump that lift. Frequently asked questions that we're going to get, so I'll head off a few that we heard at the booth yesterday, thank you. The header tank, we wanted a header tank that would work in any flight configuration. So whether you have a tri-gear, a tail dragger, a float plane, it's a different deck angle. We wanted only one set of drains. Anybody here had a leaky fuel tank drain? I've had it multiple times in my airplane. I tried, if you wonder why there's only one drain on the tank, unless you go with the float kit, you can install one extra outboard, it's because it's less things to go wrong. So we want to minimize the number of drains. The header tank is angled on the bottom like this, so no matter which configuration you're in, it's going to drain to that one point. The header tank has return ports in it. So if you're installing a Delta Hawk or another fuel system where you need a return, we don't want it to return to the wings. That's a safety issue. We want it to return to the header where it's still available to you. So header tank has size on either side, so you can slip this airplane. I've done it from 10,000 feet, 10,000 foot slip, and it's hard to bring any fuel idle, but you don't have to worry. Even if you have light fuel on the tank that's unported, it's going to stay, the engine's going to stay running. So that's a huge safety issue. It's a simple valve in the front. If you're going to run that port on the header tank, if you're going to run a tank for a long ferry, like going, skipping Canada and going to Alaska, there is that port that you can port into at that point. So talk about the pre-molded windscreen. I don't think we'll have bonding, but I don't think we'll have any hand layup on this airplane.
Yeah. So I know we've talked at the booth about the engineers at Vans were home builders, and you can tell as the kits have evolved what we've built and what we improved. And one of the things that we really don't like, or takes a lot of artistry and it's a pain and you sweat over it, let's say, is that forward windscreen fillet. And it's like, man, there has to be a better way. So what we did on this airplane, one, the windscreen has a slots that it fits into along the A-pillar and the roof line, so we were down to just that forward fairing. And what we did is we developed a pre-molded, joggled fillet fairing that match fits to the upper forward fuselage. So that allows us to do a few things. One, remove a lot of that artistry. We get a better fit, a cleaner trim on the windscreen. It drops right on. But two, should anything happen, I know I sweat over it when I take people flying that aren't used to airplanes, but it gets scratched or badly, a ring, a watch, you can replace that windscreen without having to affect the paint, without having to do all sorts of work and rebuild your fillet. So the windscreen will come out, the windscreen will go back in. So much like a Cessna airplane, other than in a lot of ways it's easier. Yeah, you can feed a piece of safety wire through the joggle, cut the soft adhesive at the bottom, dig it out, and just reinstall it just like you had before.
There's that header tank hiding down there, and there'll be a large opening under each of these pans. So this side is large enough that you can take the header tank out and service it outside the airplane. On this side, there will be room for both the pitch servo and the roll servo for the autopilot. So those are easily accessible and you don't have to run your CAN bus out to the wing anymore. Let's see what else we can see in this picture. You see those mil-spec gun rails right there. We're really excited about this fairing that we're talking about because that took a lot of sanding, at least for me. Getting that laid up, it probably took me a week's worth of work on my airplane building that. You think you can just take it out of the box and rip that on? That's definitely time ahead. Composite doors. So what you see just got us to Oshkosh on the airplane out there. But the final version will have a composite door. It'll be really deep door frames, so it's stiff. We're still, that's one item, it's a finished kit item, but we're still iterating on the final version of the door, collecting data. I'm not sure if we'll have openings in the door or not. You'll see two sets of air vents that work really well, but still some iteration to do on the door. But you'll have a latch mechanism, kind of like what you see on the flying airplane. In the very back, we have a question. Yeah. Yes. Yes, we will deliver transparencies cut to fit. So the 14 is almost there. There's a little bit along the back edge. But this windshield, yes, will be cut to fit. Hopefully, at most you may have to sand less than 040 off. I would hope we get it exact though. That's our goal. The same with the side transparency. So we're doing plexi in the top windows. We're doing plexi in the side windows. That lets us put the UV protection in there for you. Lexan, if you spill fuel on it, it's not going to be good. So we plexi all the way around and trim to fit, and then bond in. Yes, go ahead. Same for the doors. Yeah, the doors that will have a composite frame, and then just like that windshield skirt, it's going to bond in there. So yeah, and you'll be able to replace those over time. There's still more to, that's finish kit, but I guess what I'm trying to say here is, as we solve the fuselage, we're solving the finish kit items as well. The cowling's already done. I'm not showing it here, but items like that, the finish kit should be shortly behind the fuselage kit. Baggage retention. So we have multiple pillars, and under Mosaic, we have to stop that baggage coming forward to 9G. So we'll put hard points into the pillars and some sort of cargo netting there to stop that. Parallel valve motors, I already touched on that earlier. They're lightweight, you're going to lose a little bit of baggage, but it is possible.
I have a question.
Quick question in the front, and we might have another one, yeah. Go ahead.
At some point, could you speak to what's going to be the fuselage kit, what's going to be the finishing kit? In terms of like all the flap controls and all that could be in the fuselage kit?
Yes.
Okay.
So systems will be in the fuselage kit. You'll be able to build your fifth system roll system.
Okay.
Yeah.
Are you going to offer a souffle door option?
We have not finished the doors. We're still collecting data from you, Dave. Yeah. This is a two-person operation. Sorry to take Bill out of it.
We've got exciting ideas there. I think
So, yeah, I kind of skipped ahead to our exciting part there, accidentally. But let's, so I don't know if you get a scale for how far up the fuselage that's going. This is going around the curved upper portion of the fuselage, and why that makes sense is you don't want to lean down and look into your baggage door. That baggage door curves up and over the top. So to give you an idea on the scale on that largest baggage door ever in an RV, it's definitely a 180 door, to give you an idea, would be about like that. You can barely get your shoulders through. So full 2 feet wide, 22 inches in the back, and 32 across the front. You can get a full mountain bike, men's mountain bike tire through the back. You can rotate it down with the seat and everything, and go through the back and load it from the back. So this is really exciting for us. Do you want to say anything?
so you can tell an engineer makes the figure when it goes to 1,000.
Oh, that should have played.
We're very excited. Ultimately, the dream that we really want is we want to be able to stand at the airplane with that upper door open, with our back straight, look in and say, yep, we tied that down. It's secure, good to go, and close the lid. And that turned into a tall baggage door, lots of access. You can see what's going on. Of course, I have a family RV-10 that I fly a lot, and you stick yourself in it to some degree to get the thing in the back corner. We really didn't want that experience. That is certainly a design challenge, and has been a challenge to get the structure to work around this door, but it is absolutely robust, and we're very excited to show you how useful this airplane really will be, both between the main baggage door and the main door, where she's been used to access the forward section of the baggage bay, and this, which effectively is the entire bay from the aft window to the baggage bulkhead, being open on one side. It's just a huge amount of usability, it's safety. You can secure your cargo, and you can kind of get the lower tailgate door closed up and keep throwing stuff in if you need to.
There'll be a latch in the bottom door, so that'll independently latch, and then the top door will come down and latch over top of that. Gas strap for the upper. You can put chains on the side of the bottom door if you want to turn it into a camping table there. And then the bottom, swings all the way down. So we didn't want a forward hinge door that's always going to come into you as you're trying to, or you have to walk past to get to the front door to adjust baggage from the front as well. So we're proud of the baggage door. On the previous slides, we kind of showed you, like there, hint, it was there. We just didn't mention it. You see the structure that the double bulkheads and hat sections, easy to build. One piece on the, well, there's three, but they easily rivet on the inside, so easy to build that around. Your wiring for your ELT and lighting on the top goes up there, so we feel we're headed the right direction with the baggage door. On to spin testing, real quick. So spin testing is a Mosaic requirement. For those unfamiliar with spin testing, you tough the whole airplane. It's kind of an unknown. And it's the most dangerous thing that you do next to flutter testing in a development program. There's the CP of the airplane, so if you imagine a weather vane or a pterodactyl, the back had a lot of plume because the beak was really front, had a lot of area in front. So as we moved, especially as we moved the passenger forward, we don't have it on here for Oshkosh, but we built the airplane out as it would be. It was rough, that's why we didn't bring it to Oshkosh. To get that CP right, so the outer part of the airplane was correct. You might notice that some of these spin test videos if you look closely. We conducted over 70 spins. So the requirement is that you conduct a one-turn spin, and you have to keep the pro spin input in for one turn, and then you can recover. So when you look at these videos, we didn't have a chance of recovering until we let it go one turn. And this airplane's coming out in a quarter to a third turn, which is pretty amazing. You'll see that the rocket, the spin rocket, in case we need it, luckily we didn't. This airplane is well behaved. And so we wanted to march that back to 35%. So if you think of how does the airplane, what is the propensity to get into a spin at even 35% aft CG? So with that, I'm going to kind of bounce out of the presentation here. And we've all seen the spin test video, I'm sure, at the booth where you can see it, but I'll kind of jump through it here real quick, get through the takeoff. So here we're departing. This is a flaps up condition. And you see, even after we go around one turn, we're quarter to a third of the turn recovery. Now, flaps up in this airplane, you're able to spin, we were able to get the airplane into a spin. That's an aft CG condition, by the way. We were able to get it into a spin at our forward CGs. The forward-most CGs, it was hard to get this airplane to spin at all. Let this continue to play here. This is a side view. The reason you check this in the front of the airplane is you can get vortices shut off the front of the cowling that can go back and affect the tail. If you're looking for things that are blanking out the tail, you'll notice that the airplane pitches as it goes through the spin regime, and that's separation coming off the top of the fuselage, blanking out part of the tail and having it come back. And again, you see the extended nose there. Trask built a really good mimic of a final cowling. It's hard to tell. So those are all aft CG spins, and you can see how docile it is. He's holding pro spin input in all the way. And we have to go through all what that ASTM requirement says. You have to consider all combinations. So you have to have accelerated turning stalls with power. And if you think of the combinations, okay, now it's going to be stick to the right, pedal to the left, full power. You're basically trying to do a snap roll with an airplane at slow speed. It's pretty aggressive on the airframe. Some pretty aggressive maneuvering. I think this is the 360 cam. You get to see it to go around. So that's the layer RV, it will point the nose towards the ground rather aggressively. But you're able to recover quickly. Now, of course, we're not recommending spins in the airplane, but what we want to show you is we've done our due diligence spinning the aircraft. Spinning around there. And I'm going to pause here because I want to show you a couple of videos. So this is going to be forward CG with the flaps down, or forward to mid CG. Now you notice we don't really enter a spin. We're trying to make the thing spin. And we tried, and we tried. And unless you get to a really aggressive snap roll position, you're powered on, cross controlled, in a bank, we could not get flaps down to depart into a spin until we were at FCG. That aggressive maneuver will get it to depart into a spin about 28 to 30%. But it was difficult. If you think of that, you have the flaps down, and this airplane doesn't want to spin. That's a safety item. So what I'm showing you here doesn't look that impressive, but that's what it's meant to be, is not that impressive. not look aggressive. That's the realm that you're going to be flying in, and that's what we wanted to see. This is going to be a flaps. This is the other end of the spectrum where you go to flaps down aft CG. You see the difference between this and the last video. You're going to see at the beginning it doesn't want to depart into a spin, but it eventually gets into a spin. Why that's important is if you feel an airplane going into a spin, you can catch it and get it out in that first quarter turn very easily. Oh, that's flaps up. Sorry, that's flaps up, aft CG, and I had, let's see, this flaps down, aft CG. So you're going to see it not really want to go into the spin and then eventually depart into the spin. So this, you think you're in the landing configuration? No, I don't want to go there. Okay, now I'll go. You could have kicked it out at any time as it starts to fall off in that realm. So we wanted to build that safety into this airplane. And that's the spin test program in a nutshell. It's an important milestone because we've locked down the aerodynamics of the airplane. With that, just talk about kit delivery. Again, we'll look on the kit instructions. After we get back from Oshkosh, we're building a couple of static test fuselages. We need to get through the engine mount testing, so it's not a FAR requirement, but it's something that I do advance. If you view this built to 12, you'll see the little triangles on the bottom of the skin. You get a massive compression load on the bottom skin if you account for the engine at the same time as the tail. You're not required to do that by FAR 23, but we do it anyway. It simulates you're pulling up and really aggressively pitching the airplane at a VA condition. So we have that testing to do. There's asymmetric tail at the same time. So you take 75%, 100%, apply that, so you're trying to twist the fuselage. There's wing symmetric and asymmetric load, so when you pitch up an airplane, the wings actually want to rip off forward. And we need to test that, and then differential lift on the wings. So that's really going to rack that fuselage. For a high wing, that's important. Landing gear drop testing. So this is going to be an easy with Brian's gear, I feel, but we have to do it. And float loads. There aren't really float loads that I feel are indicative of what really happens on floats. If you take the FAR 23 loads. So we'll be going above and beyond there, because if you think the floats wants to go this way and the fuselage wants to go that way, you have that condition. You have going over wakes. We've already considered that, and the loads coming up, and I think I didn't show a picture of load as floats.
There's a lot of ways, and we know the way this airplane's going to be used. Like it's what we call the abuse cases, but really it's the unexpected case that we design and we add factors to, and we really add the smart weight back in, where it's really structurally efficient to make the airplane that much better, work that much, last that much longer, or prevent that repair from even happening in the first place.
So targeting deliveries in December of fuselage kits, but the main milestone is getting through this mosaic testing. And just move on to the last picture. We can go to final questions. That's the design team. Here at Vans, we also got Mark Cook helping us out. He loves to come over, and we love to have him in the background. But besides that, we have Logan. Again, he's building
He's got a Pacer project.
But he's converting it to a STOL airplane, and we said we had the right guy when we were interviewing him. He's done a lot of STOL flying on the sandbars. Jayden Goldschmidt there, Brian,
He was in the approach as we were starting the talk,
Yes.
so he was late today. But
New pilot, flying an RV-12. Trask comes off of a farm. He's one of our mechanic proto guys. It's his paw size that the openings are designed for. Carson in the background there. Carson is Emeryville grad. When he said he built his own dump trailer as his high school project and welded it himself, we said, yeah, you can work with vans. But he's a aerodynamic out of Emeryville. You have Mark in the background, the most important man, Dick Van Grunson. We hope he'd be here by this time out of the board meeting. Hasn't showed up. You have Elliot Seawin back there on that spin test, myself, and Austin Horner, who came over from the RV-12 team to join us. Been a great addition, also Aero grad. So with that, let's take some questions in the time we have left.
Do you have a picture of the final fuselage? Like, you can see that final there.
we don't have one prepared today, but we'll get something pulled together. We've done last year. We had a good line view comparison. This one I know we showed a lot of isometric views where it's pulled off to an angle. But we're doing primarily once again how those lines flow, what it looks like with the skins. We will have something to share soon. We're just not prepared for that.
That picture there, literally, we had the crew back at home working on the fuselage, and why I went to that opaque view is they were turning some skins green as they went green in the front, the very front skins, and so it was live changing as we were trying to take pictures of it. So, yeah. Okay, we have one question. I'll come back in the purple.
I want to go back to the jack screw.
Go back to the jack screw, sure.
So, how tall is that jack screw? And you got a gear at the bottom, and you got that collar at the top. How much side load is that getting put on that? And what kind of maintenance?
So what's the side load on the jack screw? And know that our jack screw is about twice the diameter of a C-180. So,
So very intentionally, there is not side load put on it. So those forward stop plates that are also the upstops are lateral rub strips as well. There's a UHMW block foot there that rides on those forward horizontal stabilizer brackets, preventing the side load from happening. The tail fits pretty tightly in there. The plastic breaks in a little bit, and that prevents the side load from coming in. It has at least for our test airplanes, we're going to see if we really need it with matched hull and CNC manufacturing, but it has a slightly eccentric bushing with the cross drill, much like the Cessna, that you can pin and crank down. We likely could even get rid of that eccentricity and the setup because our airplanes are so consistent.
yeah, we'll have a pull-out handle that we'll push on the airplane, but we kind of know that people are going to push where they shouldn't push, so that side load is important to us. Make sure that was taken up by some restraint. We had a question.
Yeah, I'm sure there are hundreds of people out in the VAF world that would like to see this slideshow. Are you going to be posting it so that they can?
We could post it, yeah. We'll talk to Mark Cook. It's in his realm and see where he goes with it.
And I get the link first.
You can get the link first, please. Definitely.
Copyrights.
Okay, we've got a couple here. Let's march back in the black.
When do you anticipate being able to sell SLSA RV-15s?
Yes, are we going to sell SLSA RV-15s? The answer is resoundingly yes, eventually. Initially, our goal is to get out fuselage kits, and then get the airplane out to the builders. Once that's established, we will migrate next year into an SLSA version. It'll take some time though. It builds so fast, but there will be SLSA versions. Flight schools have wanted this airplane, and on that note, we will be putting the gear, Brian's gear, in the tri-gear version in May. There's a question. I'll get over here. Two back. Yeah.
Are you gonna do inadvertent baggage door opening in flight testing?
Inadvertent baggage door opening in flight testing. We'll definitely test it without the door on there. Interesting. Yeah, I think it would have a chance of staying on the airplane since it's held on a piano hinge. But that's a good question.
And speaking of, so we talked about the functional reasons that the door was two pieces, but the other side of that is to help reduce the the abuse loads again that the airplane could see. So that nice short door on the wide hinges makes them dramatically stronger, stiffer, and less likely to have damage, whether that's from wind or latching problem. The way the lower door, the larger one, latches, it would be extremely improbable to get that thing to come open.
But to answer your question, yeah, we're doing that testing with the main doors off, which isn't a slam dunk test, by the way. Cessna, when they did their testing, even putting people in different seat positions sometimes caused anomalies. So there's quite a few test points, and to do that test properly, there's a lot to do there. We had a question, yeah, in the TM.
Brian, any updates on your gear?
Well, I'm really excited about it. So we decided not to show it, and essentially what that is we want to get it exactly in this configuration through the static testing. The math says it's going to work really well, have a great fatigue life, substantial weight reduction, but we want to have maybe a more dedicated announcement as we get through drop testing exactly what that looks like. But I will tell you that it is dramatically easier to work on and remove the shocks, and there are actually, you can somewhat see them, but very large access holes in the floor now. We have worked with our shock supplier, TK1 Racing, to make a shock that is custom to the RB15, and what it does is it packages it a little thinner, it uses smaller fasteners as far as the lengths, and what that does is make it so you don't have to pull them out as long, as far. And what I really mean there is there's lots of custom fittings, and all the focus there is on making it easier to work on the airplane, get them out, just to remove or even upgrade technology to better and better shocks come out. On this airplane, we've had 0 issues in the years we've been flying it now. We haven't had a nitrogen to them in 3 years. I mean, they just get worked and worked and not needed any maintenance. And it's been a really, really great product. It's a great application for it. It's so protected of this airplane.
Yeah, I'll say on the gear that the pivot point's tucked up into the fuselage, so it'll be much easier to fare that, and we'll lose a lot of drag there. J-Crap, we'll go to you next, and they'll come back across, and others, yeah.
Master Gas on gross weight, weight.
Gross weight, heavyweight. Gross weight's gonna be 2,400 pounds, I'll tell you that. And that's how light you can build it. And if you put full leather all throughout the tail cone, you're gonna have an issue. Not the back. No, in the front here.
Just a couple of thoughts. First off, in your plans, more of these kinds of pictures would be really helpful, just to see kind of where you've gone in the big picture of it.
So the comment was in the plans, like more overview pictures to give context rather than just zoomed in on the plans. Yeah.
The other suggestion would be where you're doing the left side and checking things off, and there's the right side, put a checklist for the right side as well.
Yeah, so the question was left side, right side. When we did the wing plans, we only had time to do the left side. The intent is to come back and make a left and right as time permits, but I can tell you all those drafters are making the production drawings for the fuselage right now.
Yeah.
Slash, they're making production, they're into KIs now. They have been busy
And the
over the last
tooling and
few months.
fixtures. I mean, there's a lot of form blocks in the fuselage.
Oh, yeah.
Right, so they were busy doing drawings for that. We had other questions. In the front here in the red.
Flap mechanism on the wings for the
Oh, yes.
brake. You said you were going to touch upon that.
Yeah, Brian, I almost caught you, but we kept moving. So, yeah, let me go back to that
Back to
slide.
that slide. You can see if you can zoom in. It might be difficult, but so the mechanism there. Okay, drag it in. And we had a dedicated picture and it disappeared on us. But so what we can see there is that is just where the cable turns. That is just out where the fuel tank is. There's 2 brackets with stacked poles. And that flat belt crank is I think the 5 3/4 inch diameter. It's a large belt crank on the driving ring, and the arm stretches through the slot in that adjacent rib. So that piece specifically is packaged in there real tight. Part of that is so that we can share bracketry, make it more structurally efficient. But part of that too is that it reduces all those cable loads. It's gentler on the airplane, it does really big flaps, and it's an easier, it's a less spongy flap system. We didn't have to add as much bracketry weight to get it. Now ultimately what I'm getting at is it's really large, and it's packaged tight. And the reason you don't have it right now is that that cable that goes in it has to be exactly the right length so that it'll integrate to your fuselage. And where those tensioners land, we have to be absolutely finished with and damn sure that we're not going to move them for maintenance or ease of wing removal so that you can split the system. Those cables essentially will get built to this assembly, much like you see there, and then fed through the lower access panel, fed through those two holes, which that's on me, send an email. No. And then route it through the cove, mount, and bolt down to the flat bell crank. So should someone want to make that life a little bit easier on themselves, they could leave a certain section of the main wing skin open just so that they can visually see what they're doing. But ultimately, it's very installable and very accessible. We made that decision to release it as it's closed up. I've done it myself on the airplane as it's sitting up tall on its gear, and it takes 2 tries to maybe find the right hole through the rear spar, push it through, but it's really not that bad. Yeah. So it comes in and out, and we can install that as soon as that cable length is finalized.
In the gray.
Staying on the flaps, what's the flap extension speed, and have you guys considered publishing a partial flap extension speed?
Flap expansion speed is 92 knots in any flap configuration, and it's fun. It is a lot of fun. It's not fun in Cessna 170 or 152 seats because you're worried if they're going to come out of the holes. So you have both feet on the pedals, but you can literally just point, like slip. You have an option. You can either slip or you can have more fun and just hang it on 92 knots right there, and you're just coming down. Paul, your husband, I said, push further, Paul, push further. And we finally get it 92, and then you can easily, you got so much drag in flaps 4, easily transition into that landing flare. Over to you, Brian.
And on that, it's like, okay, now I'm going 90 knots with all my flaps out. What am I going to do now? Like, it sheds so much speed so fast right as you do it. Like, it's really neat. I mean, in the airplane, especially with the vortex trainer flap, it's not shaking and angry and all that. It's just the biggest sensation you feel is the downward angle you're at, your weight into shoulder harnesses. But it's a really, really cool flap extension speed for the airplane. Very useful, wide range, and you're not going to bust through them on the go around. I'll take it off occasionally, full flap, just if I ended up doing a stop and go for whatever reason. And,
yeah, I can do circuits. If nobody's in my way, I want to do really fast landings and get back. I'll just leave it flaps 4, punch in the throttle. I won't even change the trim. Just go up around, get enough altitude to cut the throttle and go back at it.
Yeah.
So it's fun.
My favorite call from our local tower is make an accelerated landing, a short approach. There's like, you can hold speed in that airplane for so long, cut the power out 90 knots, will come up fairly quick, and just pitch and dump everything, and it just really quickly, just all that energy is gone. You have dramatic energy control in the airplanes. And honestly, it's low workload. You look like a complete expert, but the airplane just behaves. It doesn't feel like it's ahead of where you want it to be. You can just keep dumping energy out of it.
Other questions? Yes, straight back.
You mentioned RB60.
There will always be the next number. Yeah, there's about 3 different projects on the books right now.
And but truly the 15 is an absolute focus, and the kit customer getting them, the whole airplane is an absolute focus. And, we're always ambitious, and we want to take it further and do the next thing. But
yeah, the whole team is on the 15, including manufacturing. But there's always projects in the background that we're noodling. Gosh, we wander around and collect ideas for a few years, and then start the next thing.
Ultimately, like the primary daydream for the whole design team right now is to see what you guys think of the airplane. I can't wait for those demo flights. I can't wait to see all these airplanes just kind of snap together all at once. I mean, you're going to be 80 airplanes pretty quickly there, all these people that are built.
Question to green.
Yeah, so related to that, what are you guys going to offer the Airplane 15?
So it will be the next airplane. This airplane just being such a development article, like it's a long briefing. There's lots of considerations. Like it is not a truly normal polished airplane where you just kind of crack the POH and go. Right? So it will be the next airplane, but that is going to truly get them into your hands. Our airplane will be flying first, and that airplane will then pass through its testing. But definitely, we're eager to do that and we'll let you know.
Yeah, we'll need a flying airplane before we get to the fuselage, get that, release, that gets you the idea. So, yes. Dave.
How finished is the fuselage kit going to be?
How finished is the fuselage kit going to be? It is operated, so we'll be giving you regular pieces to put together. It's not a quick build kit, but yeah, it's going to be the whole airframe kit. It's going to go together really fast. I can tell you that. If you built a 12, you built a 9, but for those of you that's built a 12, the tail comes. There's a few more pieces, but it's kind of the same concept. In the front here in blue, and then we'll go to pink in the back.
Can you say a little bit about this future SLA version?
Say again?
You mentioned the future SLA.
Oh, SLSA version. Yeah. Eventually we will set this up to roll off our assembly line at vans as an SLSA version. Yes. Aircraft. In the pink, yeah.
Yeah, you're gonna still offer a ballistic recovery system also.
Ballistic recovery system. We'll look at that eventually, but out of the gate, we don't want to slow down to get people their kits, and that would slow us down. So that's going to be more long term to look at. But initially, yeah, we're just issuing the airplane as is. In the front, the purple.
Yes, so initially the EAV.
No, initially, you have a chance to build this ELSA. So we've had this under Mosaic from the beginning. You can build this as an ELSA aircraft. That is our intent. It's my intent under Mosaic that more people would go that way. You get the 4 manuals. Again, eventually we'll be able to do more and more. There's no 51% rule. So we view all these as ELSA. You'll have to do your own NCAT form if you want to go EAV, because like 12 will push me forward as ELSA. Other questions? Let's see. Oh yes, in front.
Just wanted to double check. On the fuselage kits that are coming out, the ones that you have now, are they going to be able to handle the float and the rear gear, or is there going to be different changes later on?
I'm not done 100%. The question is, will the kits that come out be able to handle the float and other gear configurations? I'm not going to 100% commit to that if we end up releasing kits early. But yes, it is our intent that they will, when we go through the testing, we are going to test tri-gear, float, and tail dragger configurations. And it is our intent that the airplanes will have all varieties, however you want to put it.
Yeah, for some unknown reason, that's not the case. It will be very clearly communicated. So.
Thank you.
Yeah, it is our intent that we have a
Yes, we do need to
vacate. Okay. Yeah, we're 1 minute away. So come see us at the booth. Thanks everybody for coming.